Okay, great. Thank you so much, Ben. It's a really great pleasure to be here, especially because yesterday I didn't know that I was coming here. I'm replacing Sophia, but I'm really glad to be here and talk about our work augmenting human survey responses with generative AI. And here our application will be economic research, and in particular, I'll be talking about willingness to accept as an estimate for consumer behavior. And this project is motivated by the notion or the observation that a lot of surveys are declining response rates. These figures are from the Labor Department, and you're going to see that in the last decade, so the first numbers are from late 2013 to early 2014, we see a big decline in response rates. For certain themes, it goes from 90% to 70%, but for some other themes like job openings, this goes from 65 to just the half of that, like 32%. So this could be really concerning if we're trying to come up with high quality data from surveys. Apart from declining response rates, we also have that the quality of data is actually declining. This is in part realized by the fact that we see that demographic patterns from non-response rates can be linked to groups that are really hard to reach. So virtually, there are certain groups of the population that are not reachable. You can think of this as really high-income people or really low-income people, people that are harder to access in terms of geographical space. Also, we see that there's a lot of dependence on online survey platforms like YouGov, MTurk, Prolific, where these platforms will host a very particular set of people who will self-select into the platforms, and that they become real experts on survey taking. And actually, if you've done one of these surveys, from time to time, you get some good feedback from these respondents saying, "Oh, probably you can update your survey in this way or the other because it's a little bit unclear or whatever." So another issue that we see in surveys is that respondents are using LLMs. So this is becoming the loop of or chasing the cat and the mouse. So the question that motivates this project is whether Gen AI can actually be a pathway to overcome the survey limitations. And the idea is there are a bunch of benefits of using Gen AI to augment human responses. And the idea here is once we get this done the right way, we can build high-frequency data that we can use to track basically live events. Think about applications to macroeconomy, where we would like to see human disasters or economic shocks live, consumer behavior, where we can test new products or even track public opinion on controversial issues. Also, generative AI can help to assess menial or repetitive tasks. So think about actually asking people about the entire repertoire of goods in Amazon. That would be a task that is huge and people would not be able to do, not only because of time, but because of a big cognitive demand that is needed to pursue that task. And also populations that are harder to reach. So some of very good research is centered on CEOs, but also we can think about some vulnerable populations that are really hard to get. So the first step in order to be able to address this question is asking whether generative AI is actually good at predicting survey responses. So there's a bunch of new literature showing that LLMs are able to produce responses that are consistent with human behavior and also economic theory. In economics, and actually John Horton and Ben Manning just released a new paper on this, psychology, sociology, computer science, and there seems to be some results that are very promising, remarkable prediction capabilities for the general social survey, and also realistic and comparable estimates for willingness to pay. So the research question that we're addressing through this project is, what are the conditions under which LLMs can reliably replicate human survey responses? And the way we address this is, first, we developed and present a framework to assess LLM-generated responses, and then we go and complete 2 economic surveys where we benchmark to standard statistical models and other human predictions. So just to summarize really quickly, in this paper, we will systematically vary the inputs to the models. So here, we will be looking at different types of data. So this could be publicly available data, and then probably you're thinking, well, what about the leakage assumption? So we're gonna also be having non-publicly accessible data. Then we're gonna vary the prompts, where we will have different perspectives as an expert or as a self. Then we're going to vary the foundational model, where we will be working with workhorse models, reasoning models, and also open weights models. And we're going to be changing the model parameters, the inputs, and we will be retraining the models. The idea here is we will try to get the best accuracy that we can, just to show in what conditions we're going to get the most out of this method. Then we will compare this to standard statistical models that we will be using if we didn't have this new technology, such as multinomial logistic regression, just trying to predict valuations as a function of all the attributes that we have from people. And also we're going to do some, just to benchmark our prediction accuracy, we're going to do some surveys with people trying to guess what the valuations of other people would be. So just to be more specific, we're going to be looking at 2 types of data. One is proprietary data. This is from a survey in the UK on willingness to accept on 22 digital goods and 5 analog goods, including reading newspapers, going to the park. These are going to be a categorical outcomes. In particular, there's going to be 9 different categories that we will try to estimate through these models, the LLMs. Then we will be looking at publicly accessible data on income in the US. As prompts, we will be varying whether the LLM will behave as an expert or as self. And then we're going to add another layer, which would be the metacognitive layer of a step-by-step reasoning. We will be varying the amount of data. So this could be just demographics, or we will be adding some benchmark data. So this will be all the other items that were considered in the survey, except for the item that we are trying to predict in this particular case. So that would be product P. And then we're going to vary models, fine-tuning. We're going to do RAG. We're going to vary as well temperature of models. I feel like the conversation on prompting and temperature was probably really hyped 1 year ago. But then actually one of the findings that we have is that that doesn't really matter in this context. So just to give you a sense of the prompting, we're going to prompt saying you're an expert. We're going to provide some demographics, and then some valuations for other goods, ask for the product or service of interest, and then give certain options. Just as a baseline accuracy, we will observe that we will benchmark our responses just to random. So this is basically just picking 1 out of the 9 categories that we have as possible options. These, as you saw here, these are numeric valuations in buckets. These are in pounds. For 1 month, it's up to 1,000 pounds. And this will be the smallest sum that anyone will be able to accept to stop using that particular good or service. And for 12 months, that would be up to 10,000 pounds. As you can see, humans are actually pretty good at predicting this, so with an accuracy of 0.4 out of 1 for 1 month. And this is basically summarizing our results. So let me show you what's in this graph. So first, we're going to have 3 panels. The workhorse models from left to right. On the horizontal axis is going to be the workhorse models. Then we're going to have the reasoning models, and then the open weights models. Then in the vertical axis, from 0 to 1 in accuracy, we're going to have a random as in around 0.1, since there were 9 categories. Then human responses above 0.4. And then we're going to have 2 different colors. In blue, that's the expert prompting. In red, that's the individual as a self prompting. So there are 3 takeaways from this figure. First, you can see that the amount of data that we provide to the model is really, really important. We will see big spikes in accuracy when we decide to provide more benchmark data. So those would be the items that were considered as part of the survey but are not directly related to the product that we care about. Then the second takeaway is that if you see blue and red bars, they're more or less in the same height. So that means that the actual prompting doesn't really matter. Or it does in certain cases, but on average, it doesn't really matter whether you're prompting as an expert or as a self, or whether you're adding this extra reasoning step-by-step layer. The third conclusion from this graph is that actually, if you look at the first and second panels, we will have that 4.0 mini is the one that outperforms the rest of the models. So it is not the case always that the big heavyweight reasoning models are going to be much better. So that's actually good news, as in lightweight, cheaper models might actually get the job done and at lower cost and more quickly. Just as an extra observation, open weights models are actually doing fairly well, especially compared to humans. But still, I mean, these are a little bit old generation. We tried this with O3, and results are pretty much similar. This is for 12 months valuations. We observed the same. Then we went ahead and we did we retrained the models, and we actually see that there's a nice increase in accuracy once we do this. That goes from about 14% to 21% boost. And then when we do RAG, in this particular case, we're going to feed the model with news in the UK that are especially related to the digital good or product. And we see that there's an increase in about 6 to 9% in that accuracy. Another good observation is there's a lot of heterogeneity in terms of goods and services. We're going to get really, really good at predicting online goods and services. You're going to see like online search engines are predicted in about 0.94, which was really surprising. But then we're going to get worse with other type of goods like going to the park or having a TV set at home. So it's important always when we do this to look at heterogeneity. So just as an overview of findings, we see that the accuracy is going to be a function of the amount of data and the value of data that we provide to these models, while fine-tuning in RAG actually delivered a boost in accuracy. Prompting techniques and temperature actually did not that much, so we would suggest not emphasizing that too much or spending too much time on that. Then we will see a lot of heterogeneity in terms of models, but as well for certain populations, we see that young, wealthy, educated respondents were overestimated in terms of valuations, but we also see good news where vulnerable populations, low income, older people, valuations were actually predicted with high accuracy. Just as a takeaways, like best practices is trying to provide the best possible fine-grained data to this model so that then we can extrapolate to, for example, new products. Then doing the fine-tuning is definitely worth it. And then always include humans in the loop as we do here where we validate the answers. And the idea will be recalibrating and doing this continuously so that we can have a good hybrid high-frequency data sets that we can use for other purposes. That would be all for me. But thank you so much, and all your questions are very much welcome. Mm-hmm.
Could you go back to the result?
Yeah, of course. This result?
You make much of that human benchmark, but can you help me understand, did the human access the same type of information that the higher two of the bars, I mean, all the benchmark evaluations were, or were they maybe more like a shot in the dark and therefore it's not a fair comparison?
It's a great question. No, they actually got the information from the high two bars. So they got all the information, and it's a little bit surprising actually that these models like O1 preview, they got it right without having much more information. They got it around the same as humans with information.
What would be your take on the fact that, for Romini, with this amount of data seems to be so much better?
Yeah, I think that in part is because once we include so much data, maybe the models are over-conditioned on that information. So the idea is maybe we're kind of distracting the model by saying, you should include this piece of information in your answer. And sometimes that is a valuable piece of information, but sometimes it's not. So that's at least what I think it's going on. Obviously, if you have a really, really bad model, then that is not going to do much. Okay.
Thank you.
Yeah, thank you.